a mini tutorial about lookup controllers and how to turn global rotations to local rotations, which can be a pain in the butt, and I didn't find good tutorials when I was doing or sources when I was doing this myself, so I thought that this might help somebody. So basically this is the setup that I have. I have a sort of landing gear. This is an actual issue that I was just dealing with on my own project. So I have a landing gear with a hydraulic cylinder, and I want the upper and lower part of the hydraulic cylinder just to use look at constraints, sort of. I mean, it's not just called constraint here, but basically to look at each other so that they follow nicely and look functional. And then I'll recreate this, so then we'll go through it, but I have another one of it tilted because that's kind of where the issues arise if you don't do the rotations correctly into the local space. So let me stop this, and we'll do it again. I'll leave this one as a copy if I need to cheat and check from my previous one. So let's create a blueprint for that one. Leg alt. You will probably see that typing is not my strong point. What's going on? Okay, whatever. Yeah. So here's the blueprint actor, and I'll just I'll create first a scene. Instead of the default route, I'll create a scene component. Scene, and if you drag it to the default scene, it replaces it, and then I'll call it root. This is, then I have the meshes here. I'll drag them here. Now, if you're doing anything like this, you have to put a little bit thought of where the pivots are and how they are lined up. Everything is in these assets is saved so that they are in the origin. Can't recall if they come that way here. But then I actually, when I'm doing this kind of work, then I simply type them out. I have where I store data in general, like my to-do lists and whatever. I use Notion, so then I have a place where I type in the values, the x, y, and z of these relative locations, so that I can construct it nicely. But here we can probably just go eyeballing it quite a bit. So the cylinder and the top pin, you'll see soon, they are one item, and then the piston is the thing that should look at the cylinder. I've seen production, and the eyeballing happens there too. I prefer actually knowing the dimensions, so that if you have to start troubleshooting and things go weird, you know exactly. And then if you need to update something in your 3D software, you're doing something that you're not like, and you don't have to end up eyeballing again and then things break and stuff like that. So, but now they are in the right place. But let's think of the hierarchy a little bit. We want this to rotate now from this pivot, and it doesn't have that pivot. So I'll create a scene component for the very root of the leg, and I'll call it hip joint, and that can be attached to the root, and again that should be eyeballed somewhere there. Good enough. Top pin and the cylinder, which is the top part. they will stay linked to the root. They don't move with the movement, but then the frame, which is this main part, that should move with the hip joint, and then the paw, let me call it foot, it maybe is easier to understand. Foot should be attached to that, and then the piston, which is the lower part of the cylinder, should be attached to the foot. So now the hierarchy is right. So should I rotate this? The leg follows, but the upper part of the cylinder doesn't. Okay, but now it's still totally dumb. So let's go into the event graphs. Here is a little thing. If you saw this thing, if I press play, it's constantly moving. So I'll show you how I do. I don't know if it's how others do it, but this is how I do it. I'll do a little bit of a debug action now that it's not actually plugged into any real data. So I'll create a timeline for the actual animation. Add timeline, and let's call it debug anim. And if you double click it, then you get to the actually tweak the timeline, and you can create tracks here. So I'm gonna create a flow track, and by right clicking on the timeline, well, you can zoom as you wish. I'm gonna add keys to basically every second. I'll change the values later. It's a bit annoying that it doesn't like snap to anything. Maybe there is a way of snapping it, but I don't know how. And I make these to go from between 1 and 0 and -1. That way I can use always a multiplier to get something else out of it. Or yeah, and then we can select all the keys that we want and make them like that, and we can make them flat, except this one I don't want. So this is the sort of a sine wave-ish. You could actually use sine wave too, but sometimes it is nice, like in my previous version I have it or if you look at the other leg, it does a slow one and then it does a quick one. So you can have any kind of curves. And then you can create several tracks here. So if you had like 2 different movements, then you could have one track with a fast oscillation and one with a slower one, or linear movement or whatever. Anyway, but I hope this makes sense for anybody who has worked with animations a little bit. This is the time progressing, and then it goes up and down. This is the value that it's going to get. So at 1 second, you're going to get this. At half second, you're going to get this. At 0.7 second here, 1.5 seconds, you're going to get this. 2 seconds this, and so on. Should be pretty self-explanatory. So then now we have something that we can get a value out of. Now I'm going to put it to tick here. And if I put this to play, if I put play, it plays the whole thing once. If I put play from start, every time this happens, it's going to start the sequence from the beginning. Now, as I use tick, it means that 90 times a second or 60 times a second, it's going to start. So let's do once. With do once, we can do it so that it does it only once until it's finished, and then we'll reset it, and then it's going to do it again. So do once, I don't know if it's familiar, it's very self-explanatory in a sense. It does whatever is after it only once until it's being reset. So, and here is the new track. Let's I'll actually call the new track how do I rename it there? Debug anim. debug anim track. And now we're going to take the hip joint and set its relative rotation. Set relative rotation. I'm going to right click here and split the pin because it's only the y-axis that we want to animate. You can check from the hip joint. It's the green y-axis. Oops, that was moving. It's this axis that we want to animate. So I'm going to pull the anim track to there. And now we can test it. Let's put this thing in there. I'm running out of screen space. I have 2 screens, but then you won't see. Leg alt. We could actually do a thing. I'll do a different material for it so that we can recognize it. Create material instance. Alt frame color. Again, capital L. That's not how it's supposed to go, but it happens. Okay, it's the Komatsu. It's Komatsu that has this color. Japanese excavator brand. I've been looking at that kind of stuff. Roughness. That's good enough. Alt frame color. Save it. Oops, that's the wrong window. Alt. I'm going to select the frame and just put the alt color here. Do I have the alt? Oops. Easily accessible here. Yeah. Okay, so this is the new one. Pretty ugly color. Compile, save, play. Now we can see that it's oscillating. It should keep oscillating, but it doesn't. Let's go and check. I did something wrong. Play from start. It should be play from start. Play is just play, and then when it's done, it's done. Play from start always starts it to play from the beginning. Now it should be looping, doing its thing. Little pause there at the end. Movement is very little because the animation was from 1 to -1. So let's multiply it by 12.5 just because I happen to know that it works. And then we can do compile, save, play. Okay, so now we have the debug movement there, so that when we start playing with the actual look at, we know if it works. Now, it's not complicated. We'll need the 2 things that look at each other's, which would be the cylinder and the piston of the damper. Damper cylinder, damper piston. Obviously the look at points could be reference points if your pivots are weird or like you're not actually using those pivots. But now these ones just happen to be so that the pivot of the cylinder is there and the pivot of the piston is there, so they can look at each other's, and that's fine. Now get find look at. So it's find look at. Oh yeah, I shouldn't be pulling it from that because it doesn't. And then I need to get the local, world location. get annoying. Well, I'll do it like this. Damper piston. Just unnecessarily did that. Just add it even got to get set. It shouldn't be that hard. Can't you really do it without it suggesting that already what it puts there? Okay. So now we get the location of those two pivots, the top and the bottom. And the piston is the, if we do the top one, the piston is the target. And the cylinder is the start. And now if we do a pull, Control V, set relative location, I'll recombine this. I'll say, oops, what's wrong? Target. Whose rotation are we fixing? We're fixing the damper cylinders. Play. Now we can see that it's swinging. We're making progress. It's swinging. It's not pointing at the right direction, but it is more changing its orientation. And that is because now there is a 90-degree offset that we need to put there. So we could actually just do this, that we split these. Also, we only need the Y rotation, but I'm now gonna pipe because there is an issue that I'll explain in a bit. Plus 90. Now it could be -2, but I can't recall. Let's see. Oops. Yes, as we see, now it is pointing at the right direction. The top part is now pointing to the lower pivot there. Now, this is all cool. I'm gonna make it also, I'll explain it later, but I'll make it so that just like here, the foot stays flat. So it doesn't, the actual orange or tan foot part doesn't stay glued to the frame. So let's do that first, and I'll show you. I'm actually doing it to simplify things a little bit, but let's see. So I'll rotate it, counter this. So when this rotates down, this will rotate the opposite direction, so it stays flat all the time. So I'm just gonna -1 this thing, multiplied by -1. Float -1. Compile. Oh, again, I'm missing the target, the foot. I need to do some cleanup. It's not very clear here. I'll actually do some actual annotation in a bit, or commenting out. Find, look at rotation. Really, the all caps wasn't necessary. Compile, save, and this could be. This is not ultra tidy now. I see all these super tidy blueprints people do, and then they comment like, "Oh, it's very dirty." my stuff gets a bit messy sometimes, but I'll try to clean it afterwards. Counter rotate foot, and this would be rotate whole leg. Now, this is getting too long, but now we can see that the foot is staying flat, so it's not stuck to the blue part, but it's actually staying flat. And now I'm gonna just do the same rotation actually to the with the same plus 90 to the pin. I mean the piston part. So I can just copy paste. Now this is there's gonna be a hiccup. This is gonna work for now, but it's not actually working. So I'll explain it in a little bit. Which is the relative to local rotation. And also you can get the lookat's working pretty easily, but then when you want the this should be in the middle. But when you start moving in 3D space, then funny stuff happens. Or sometimes you want to just use one axis for rotation, and that's why also the relative locations are nice. But now this should work so that now both of those look at each other's. Beautiful. We have a hydraulic cylinder working. It does separate a little bit. I'll fix the offset a little bit. I have the amount of rotation was 12.5, but I need to offset it a little bit. That's the kind of the range where it's now oscillating in between, but I'll add there 3 degrees because I've done this before. And if I recall right, this should make it so that it matches the oops, oh, is it the wrong save? No. Now it stays in there. So that's obviously just matter of the geometry, like what is the limits of the design, that how far in and out can you move. So now it works. But we shouldn't congratulate ourselves too much yet, because if I make a copy of it and sort of rotate it arbitrarily and hit play, something horrible is going to happen. That thing is all twisted, and it's likely gonna do some weird rotations and like around its axis and all that. So boo-hoo, it didn't work. How come we're so unfortunate? It's because they are rotating now. It's finding the rotation in the world space. So as long as this is aligned to the world space, this whole thing, it works. So my rotations are here 0, 0, 0. In fact, I think that all I have to do is that. That's, even if it's like 90, it's probably gonna do crazy stuff. Yeah. Even though it's sort of square to the world. So what do we have to do? What happens here is that it finds the lookat rotation, and it gets the rotation. I'll unplug these and recombine this. So it's a rotation, and it is in the world space. So it doesn't matter how your vehicle or setup is aligned, it's going to give you a rotation. We could, of course, set world rotation here, but that would still have the problem that we don't exactly choose the up nodes, like, and we can't limit what around what axis it's doing it. In fact, I'm gonna try it This is gonna get convoluted, but I'm gonna try it with the world rotation. Set world rotation. Rotation. I don't care whose rotation you're gonna try to set. And then this is the piston and this is the damper. Okay, let's see what happens. Now we don't have the 90 degrees there, but that's actually to illustrate the problem. Well, first of all, we see that they all point random directions anyway, even though they're using the world rotation. But that there is no sensible way of setting the offset when it's world rotation, because there is we don't have the isolated we don't have isolated the axis that we actually want to operate on. So it's totally sort of arbitrary. Even if we found the right direction, what is going to happen is it's likely these things are, for example, going to spin around its axis. So we might be with world rotations, we might be able to get this to point there, but we would not have good control over whether this is aligned with the pin, and then suddenly this might spin around, and that's very typical with a look at rotations, and that's why usually in like 3D software you can choose an up node or something like that, reference coordinate system, and that's exactly what we're going to do here. So let's forget those, and we're going to be using the set relative location, but we have to turn the world rotation to relative location. And to do that, we'll have to first turn the rotation into a vector. And this is the part where I just do this without understanding exactly very well the math of what's happening. But it works. So just do what I do and it works. So we're going to turn it to a vector, and then you can unrotate vector. Oops. And basically this means that it's gonna rotate the vector or create a vector that is in a different coordinate space. So I'm sure with paper I could illustrate it a little bit better, but here it's we can just think it is as get world location rotation, I mean world rotation. So now we're giving it a reference rotation, and it's going to turn that vector to be aligned with that one. So it's going to be the same direction, but it's going to be measured in relation to this coordinate system. And now we have to turn it back to rotation. So actually we could just forget the 90 degrees for a second, and if I pull it to a rotation, oops, that's not rotation yet. It's gonna do the rotation from vector x vector. I did it like that because I didn't remember the name of the command. But well, we can test it now. It should work. The only thing is that now the 90 degree offset required is not there. But now otherwise, compile, save, play. Now we should have 3, and they are all equally aligned. They are all messed up, but they are equally messed up. So that's social democracy there. No, I'm just joking. Social democracy is mostly very good. So we need to do still the break. And then add to the to the y, and make rotator. And this should go to the Y. Until that. I could have just broken that and pulled these values individual there, but now this is the same exact thing. Oops. Ding, ding, ding. And that's good, kind of lost. It's funny how I did this the first time. Everything's below and the objects are above. I am not always the most super ultra consistent guy. Fine, look at rotation. We could fix this. Find, look at rotation and turn it to local. And now we have 3 cylinders all doing what they're supposed to do very nicely. And what I'm not really going in here too much is but this is the way also to isolate it, so that if you have a, let's say a tripod or an anti-aircraft cannon, and you want to take that rotation and split it into, isolate it into different axes, so the one joint does one rotation, for example. That's where also this is very handy, because now you can make that the X rotates one joint and the Y rotates another, etc., so that you can split it, that they are operating different things. Because sometimes the with a look at, you want just one axis, in this case two, but that's kind of makes sense because we're working in a plane. But it might be that we have an arrow that needs to point at the direction of the bird, but then the bird is flying up and down and in all kinds of directions. We are not wanting the arrow to actually point up from the plane, but just rotate around the plane. So this would work nicely there too. I think that's it. If you're into VR things, check Patrol Mars. Totally should. Let's hope that I'll get it out into a playable form sometime pretty soon, at least for a playtest. And then I want feedback and lots of players. Cheers.